Hello everyone. So today we are going to write a program for searching. Actually, our main objective is to understand the binary search. You saw the play how a person can easily get a search a number uh, in a list of numbers, sorted numbers, very easily in very less number of steps. We'll see why binary search works. But before that, we understand how to simply search a number in a list of given numbers. For that, we will use the linear search. It's a conventional simple search. We'll go through each values and try to find our element what we want to find in that list, and we'll see how many number of steps it takes, and then we'll switch to binary search. So I will start my spider. I will type spider in my terminal and wait for it. Okay. Okay, I'll write my program in a new file, untitled 0. I'll change the name. So what I want first I want a list of numbers. For this program, we will take the numbers in sorted order, in ascending order. The numbers will always be like this: 1, 2, 3, 4, 5, 6, something like that. I mean, it should always be sorted. I mean, the numbers will always be in ascending order. First, I will create a list of numbers. For that, I will write a row for I in range. Let's say I want numbers from 1 to 1000. 1001. In range, if I want a number from let's say 1 to n, then I have to give the argument as n plus 1, because it always prints up to a number less than the given number. I will write here, let me save this as linear search. Okay, awesome. For that I need a list, so let me write the name as element. If I give a simple bracket, it will create a list. I will use this. So in order to add elements into a list, there is a function named append. I will just type element dot. See, it will show you all the functions which you can use with the list. That is the beauty with spider. I will just click tab and it will give me the append value, and I will write here y. That's it. I've created the list. Okay, that's it. I can just run this to see my list. Okay, I run the program. I'll just type element and it will show me the numbers from 1 to 1000. You can see I have all the numbers from 1 to 1000. Awesome. So we recommend you to write all the programs in function. So let me create a function here which I can easily call def linear search, and I will give the range here, let's say n, so that n I can use here. Also, I will give a number as a parameter x which I want to find. Now let's see this. I will give the indentation. Okay, awesome. This is done. I've created my list of numbers. Now what I want to search this element x in this list. For that I will write another loop for I in. See, now my list is uh, uh, complete. I have created the list. I can just iterate through the elements of this list, which is very easy. Just I have to write, since list is iteratable. What do I mean by iteratable? You can just Google it. You will understand what is iteratable. There are some elements in Python which are iteratable, and there are some which are not iteratable. If it is iteratable, you can go through it like a loop. So I will write for I in the list name, which is element. Okay. See, here element was created. I can I can go through it here also. I in element, and if I just print it, it will give me the elements. So I can iterate through the elements of element. Okay, for I in element. Okay, now I'm iterating over the values of element, and I will write if only one if condition. If I is equal to my number x, which I want to find, and I will just print yes, I found my number at position, and I will give the position as str. Okay, since in this example the numbers are sorted from 1 to n, I can just write str I minus 1, or like simply I can write stri. Okay, awesome. Let me write a column here. Okay, I have to also print that whether I found the number or not. If I didn't find any number, so for that I will use a flag value. Let's say flag is equal to 0. Okay, initially the value is 0. If I found this number, then I will put the flag value to 1. That's it. After that I will just write a if condition. If flag is equal to 0, I'll print number is not found. That's it. Cool. So my program is complete. Now let me just run this, and let's see this. I will just call the function linear search. See, it is whenever I type this argument, it will show me that it needs 2 arguments, n and x. So n is my range, so here I will put 1001, and x what number. Let's say I want to search 50. Okay, just type and it will show me yes, I found my number at position 50 because the number is sorted. Okay, cool. Now I want to know how many iteration it took for me to get to this number. So for that, what I will do, I will create a variable count here with 0 initial value, and whenever I am going through an element here, I will do count plus is equal to 1. I am increasing the value of count by 1, and if I don't need to, whenever I find a number in the list, I don't need to go again, go through the other elements of the list. So I will just break the loop here, because I don't need to go to find go to look at other numbers, because I already got my number. So yeah, here I will break, and if flag is 0, then it will find, and I will print the count. That's it. Let me write here, number of iterations is equal to, okay, this is column there, plus str, because I need to change this into string. Awesome, it's done. Let me check. In your search, give me 1000, sorry, 1001. The number is 57, let's say. Okay, now you can see, yes, I found my number at position 57. Number of iteration it is taking is 57, because before 57 I have to check all the numbers 1 2 3 4 5 6 7 8 9 up to this whole things. Then I will go to the 57. So you can see that if the number of elements in the list are very huge, let's say 1 million, and you want to search a number which is very far end, let's say the number I want to search is 1 million only, then it will take 1 million, near 1 million iteration to find that number, which is a very huge. In the game we saw that when we can use the advantage of sorted number. Whenever a number is elements in an array or a list is sorted, we can use that extra information for searching a particular number easily. That is the crux of binary search. So we'll see how we can use this extra information to search a number in a list of sorted numbers, and drastically decrease the number of iteration, so that we can in very less number of iteration, and or to say in a very less number of time, in very less time we can search the number. So in next video we'll see the binary search, and we'll see how we played that game.